Hello students, let's discuss the question. In this question, we have to name the type of the quadrilateral form, if any, by the following points and give reason for your answer. So in the first part, we are given the points, which is -1, -2, 1, 0, -1, 2 and -3, 0. So these 4 points are given. We have to name the type of the quadrilateral form. Let's say this is the quadrilateral we are making here. Let's say this is the point A, which is -1, -2. This is the point B, which is 1, 0. This is the point C, which is -1, 2, and this is the point D, which is -3, 0. So here we are having the point A is -1, -2, point B is 1, 0, point C is -3, 0, and the point it's point D. -3, 0 is the point D, and the point C is -1, 2. So these are the point. So we have to find out the distance AB, BC, CD and AD in order to find out the type of the quadrilateral form. So we are going to find the distance AB. So AB is given by the distance formula, that is equals to x2 minus x1 to its whole square plus y2 minus y1 to its whole square. So point A is -1, -2 and point B is 1, 0. So this is x1, y1, this is x2, y2. Plugging the points here, this is equals to under root of x2 minus x1, that is equals to 1 minus of -1 to its whole square plus y2, that is equals to 0 minus of -2 to its whole square. So this from here is equals to 1 minus of minus plus 1 to its whole square is equals to 2. Square of 2 is 4, and plus 2 minus plus 2, and the square of plus 2 is 4. So plus 4 is equals to 8. So from here we get the value of AB, which is equals to under root 8, or we can say that AB is equals to 2 under root 2. In the same way, now find the value of the BC. BC from here is equals to point B is 1, 0, and the point C is -1, 2. This is x1, y1, this is x2, y2. So this from here is equals to x2 minus x1, that is minus of 1 to its whole square, plus y2 minus y1, that is 2 minus 0 to its whole square. -1 is plus 2, square of plus 2 is 4, and square of 2 is 4. So from here we get the value of BC, which is equals to under root 8, and under root 8 is equals to 2 under root 2. So from here we get the value of BC, which is equals to 2 under root 2. Now we are going to find out the value of the CD. Again CD we are going to use the distance formula. We are having the point C, which is equals to -1, 2, and we are having the point D, which is equals to -3, 0. This is x1, this is y1, this is x2, this is y2. This is x2 minus x1, so that is equals to -3 minus of -1 to its whole square plus y2 minus y1, that is 0 minus 2 to its whole square. So this from here is equals to -3 and plus 1 is -2, and the square of -2 plus square of -2 to its whole square. So square of -2 is 4, and the square of -2 is 4. So 4 plus 4 is equals to 8. So from here we get the value of CD, which is equals to 2 under root 2. Now we are going to find the value of AD. Again we are having the point A, which is equals to -1, -2, and we are having the point D, which is equals to -3, 0. So distance formula from here is equals to x2 minus x1. A is x1, y1, B is x2, y2. So this from here is equals to -3 minus of -1 to its whole square and the point B is equals to 0 minus 2, minus of -2 to its whole square. So -3 plus 1 is -2, square of -2 is plus 4, and the square of -2 is again equals to plus 4. So from here we get the value of AD, which is equals to under root 8, and under root 8 is 2 under root 2. So from here we get to know that all the sides are equal, which means AB is equals to BC is equals to CD, which is equals to DA. This all sides are equal. So we can say that it can be rhombus or a square. To check if it is a square, we have to find out the diagonals AC and BD. If both the diagonals are equal, then we can say that this is a square. So finding AC, again using the distance formula, we are having the point A, which is -1, -2, which is x1, y1, and we are having the point C, which is -1, 2. This is x2, y2. So x2 minus x1, that is equals to -1 minus of -1 to its whole square, plus y2 minus y1, that is 2 of minus of 2 to its whole square. So this from here is equals to -1 and +1, that is 0, square of 0 is 0, minus 2 plus 2 is 4, square of 4 is 16. So from here we get the value of AC, which is equals to 4. In the same way, we are going to find out the value of the BD. So BD from here is equals to, point B is equals to 1, 0, which is x1, y1, and the point D is -3, 0, which is x2, y2. Plug the point x2 minus x1, that is -3 minus 1 to its whole square, plus y2 minus 1 y1, that is 0 minus 0 to its whole square. So BD from here is equals to 4 square. 4 square is 16. Under root 16 is 4. So from here we get the value of BD, which is equals to 4. So from here AB is equals to BC is equals to CD is equals to DA, which is equals to 2 under root 2, and AC is equals to BD, which is equals to 4. So both diagonals are equal, all the sides are equal. So we can say that if all the sides and diagonals are equal, so we can say that ABCD is a square. So this is the answer to the first part of this question. Now let's move to the next part. In this second part, we are given the 4 points. These 4 points are -35, 31, 03, and -1, -4. We have to find out the type of the quadrilateral form. Let's say we are making the quadrilateral here. This is the point A, point B, point C, point D. Let's say point A is -35, point B is 31, point C is 03, and let's say point D is -1, -4. -1, -4. So we are having these points. We have to find out the distance AB, BC, CD, and AD. So we are going to use the distance formula. Let's say firstly we are going to find out the AB, where we are having the point A, which is -3, 5. We are having the point B, which is 3, 1. So distance formula from here, AB is equals to the under root of x2 minus x1 to its whole square, plus y2 minus y1 to its whole square. So point A is x1, y1, B is x2, y2. Now plugging the values of these points here. So this from here is equals to under root of 3 minus of -3 to its whole square, plus y2 minus y1, that is equals to 1 minus 5 to its whole square. So 3 plus 3 is 6, square of 6 is 36, and 1 minus 5 is 4, square of 4 is 16. So from here we get the value of the AB, that is equals to under root 56. This is the value of the AB. Now we are going to find out the value of BC again using the distance formula. We are having the point B, which is 3, 1, and we are having the point C, which is 0, 3. So point B is x1, y1, point C is x2, y2. So plug the value. X2 is 0, minus x1 is 3 to its whole square, plus y2 is 3, minus y1 is 1 to its whole square. So BC from here is equals to square of 3 is 9, and 2 minus 1 is 3 minus 1 is 2, square of 2 is 4. So from here we get the value of BC, that is equals to under root 13. Now we are going to find out the value of the CD. Again using the distance formula from here, we are having the point C, which is equals to 0, 3, and we are having the point D, which is equals to -1, -4. So this is x1, this is y1, this is x2, this is y2. So x2 minus x1, that is equals to -1 minus 0 to its whole square, plus y2 minus y1, that is -4 minus 3 to its whole square. -1 and 0 to its square is -1, and square of -1 is +1. -4 and -3 is -7. Square of -7 is 49. So from here we get the value of CD, that is equals to under root 50. Now we are going to find out the value of DA. Again using the distance formula, we are having the point D, which is -1, minus 4. We are having the point A, which is minus 3 and 5. So dA is equals to under root of x2 minus x1, that is equals to minus 1 minus of minus 3 to its whole square plus y2 minus y1, that is 5 minus of minus 4 to its whole square. So this from here is equals to minus 1 plus 3 is minus 2, minus 1 plus 3 is plus 2, square of plus 2 is 4, plus 5 plus 4 is 9, square of 9 is 81. So from here we get the value of dA, which is equals to under root of 85. So here all the values are different. AB is equals to under root 52. BC is equals to under root 13. CD is equals to under root 50 and AD is equals to under root 85. So AB is not equals to BC, which is not equals to CD, which is not equals to AD. So we can say that these points are not forming a quadrilateral. So this is not a quadrilateral. Now let's move to the part third. The points which are there in the B is not forming a quadrilateral. So we are going to plot these points on the graph. We are having the point C, we are having the point A, which is minus 3, 5. Let's say minus 3, 5 will be somewhere here in the graph. Then we are having the point C, which is 0, 3. Let's say 0, 3 will be somewhere here. We are having the point, this is the point A, this is the point C. Point B is here, which is 3, 1. And we are having the point D, which is equals to minus 1, minus 4. Let's say this is the point B. When we join all these points, we get a figure which is similar to triangle. So we can say that ABCD is triangle. So this is the answer to the second part. Now let's move to the third part. Now in the third part again we are given the 4 points, which are 4, 5, 7, 6, 4, 3 and 1, 2. So let's say we are doing a quadrilateral. So this is the quadrilateral. Here is the point A, which is let's say 4, 5. Here we are having the point B, which is 7, 6. We are having the point C, which is 4, 3. And we are having the point D, which is 1, 2. So we have to find out the sides AB, BC, CD and DA in order to find whether it is a quadrilateral, what is the type of the quadrilateral. So here let's finding the point AB. So we are going to use the distance formula, which is x2 minus x1 to its whole square plus y2 minus y1 to its whole square. So we are having the point A, which is 4, 5 and we are having the point B, which is 7, 6. So this is x1, y1, this is x2, y2. So plug the value here. X2 is 7, x1 is 4. So 7 minus 4 to its whole square plus 6 minus 5 to its whole square. 7 minus 4 is 3, square of 3 is 9. 6 minus 5 is 1, square of 1 is 1. So from here we get the value of AB, which is equals to under root 10. Now we are going to find the value of BC. Again, in order to find the value of BC, we are going to use distance formula. We are having the point B, which is 7, 6. We are having the point C, which is 4, 3. So this is x1, y1. This is x2, y2. So plug the value x2 minus x1, that is equals to 4 minus 7 to its whole square plus y2 minus y1, that is equals to 3 minus 6 to its whole square. 4 minus 7 is 3, square of 3 is 9. 3 minus 6 is 3, square of 3 is 9. So from here we get the value of BC, which is equals to under root 18. Now we are going to find the value of CD. For CD we are having the point C, which is 4, 3 and we are having the point D, which is 1, 2. So point C is x1, y1, point D is x2, y2. So CD from here is equals to x2 minus x1, that is equals to 1 minus 4 to its whole square plus y2 minus y1, that is 2 minus 3 to its whole square. So 1 minus 4 is minus 3, square of minus 3 is 9 and 2 minus 3 is minus 1, square of minus 1 is 1. So from here we get the value of CD, that is equals to under root 10. This is the value of CD. Now we are going to find out the value of AD. So the point AD, we are having the value of the point A, which is 4, 5. We are having the value of point D, which is 1, 2. So this is x1, y1, this is x2, y2. So the value of the AD from here is equals to under root x2 minus x1, that is equals to 1 minus 4 to its whole square, plus y2 minus y1, that is 2 minus 5 to its whole square. So this is equals to 1 minus 4, that is minus 3, square of minus 3 is 9, and 2 minus 5 is 3, and the square of 3 is 9. So from here we get the value of the point AD, that is equals to under root 18. So from here we get value, that is AB is equals to CD, which is equals to the under root 10, and AD is equals to BC, which is equals to the under root 18. Opposite sides are equal. Both pairs of the opposite side of quadrilateral are equal. So we can say that the quadrilateral ABCD is a parallelogram. So this is the answer to the given question. So students, in order to solve this problem, we use the distance formula. I hope you understood the concept well. Thank you.
Don't forget to like and subscribe.